Okay, good evening, everyone. We're going to be doing a version of Lean Coffee tonight. You will see that there are Post-its and pens at your tables. If you don't have Post-its and pens, raise your hand and we will get you some. Has anyone here been to a Lean Coffee before? Okay, so follow their lead. Basically, this is the way it works. There is a Kanban board in the back there, and as you guys have questions, please note your question, one question per Post-it, hand it up. Nora and I will come by and grab those and put those on the to-do column. And then when Kris is done with his introductory remarks on the topics, we will move this up. You will rush up and use little check marks using 3 votes to help us rank the topics. You can use all of your votes on one Post-it, or you can spread them all over the place. We're doing this because we know we have a lot of content, and Kris is going to the bar afterwards. And he can talk all hour, or he can talk for 20 minutes, however long it takes. And he brought toys, so it could take a while. You can touch the things on the table. We still have to be out of here at 8:30, however, and I was a little bit concerned that we might not get out of here at 8:30. So we will reiterate these instructions as we move things up to the front, and there might be a last call for topics. Please don't be shy. Just write your question down and hold it up, and we'll come by and grab them. I was asking Kris when I met him, it felt longer ago than last November because he's gotten really involved, comes to the puppet events, comes to the pub events, and he was making a lot of great observations. So I started talking to him about what he does, and it wasn't software, so I was fascinated. I'm always fascinated when people are using Agile outside of software. Actually, Kris Dobelstein works for Dynan Avionics, software and hardware guidance systems for airplanes, I think it is. He'll tell us in a minute. And he has some interesting philosophical precepts, a couple of which are in his bio that I think you should be aware of. He says that he believes technology serves 2 purposes. 1, to make the human experience better, and 2, to enable personal and professional growth through the development of said technology. I like the way that sounds. He's going to be a very entertaining speaker this evening, and please support him by putting your questions on Post-it notes.
Well, when I first met Jean, I thanked her for organizing these things and getting us all together because it was educational and it gave me some insight into the Agilists in the Portland area. And she looked at me and she said, you know, you could help, right? So I was like, well, I have 4 kids and I'm busy and I don't know if I can do that. And she said, well, that's what people usually say. Not the 4 kids part, but the busy. But everybody has 4 kids, right? That's just normal. It's actually kind of weird. But so I thought about it and I said, you know, I think it would be cool if there was a series of talks or a series of speakers that would address how Agile is used outside of software development. So like non-traditional applications. I myself happen to use it to develop hardware, and I'll get into that in a moment. But maybe this can serve as an example of Scrum or Agile or some other type of Agile-oriented methodology used in non-software development. So how many hardware-y or electrical engineering people or maker people are in the room right now? All right. So my fellow brethren. So like Jean said, we've got some show and tell up here. So my company makes not guidance systems, but primary flight displays and all the modules and things that hook up to them for small airplanes. So attitude or inertial measurement units, engine monitoring systems. We make a full-blown autopilot system. You put it all on a small airplane and you basically turn it into a robot that will fly you from one airport to the next. Our claim to fame is that we'll give you a whole system for under $20,000. So the next highest up competitive system is probably $30,000 or $40,000. So that's what we do. Afterwards, feel free to come up and touch these things. This display right here is the main focal point of tonight's talk, and this is something that we're working on right now. It actually has a Raspberry Pi single board computer inside of it. So that's an avenue we have never taken before, but we're just trying it. So Again, thank you for having me. Gene already introduced me. I work at Dynon Avionics, and I'm here to tell you about how we used Scrum to accomplish something what I think is awesome in a relatively short amount of time. But it ultimately changed the way that we thought about hardware development. Tonight I'll review the conditions that led us to try Scrum, the steps we took to adopt and deploy it to our development teams, some of the difficulties we had in the early days, some of the practical ways we changed our approach to hardware development, what we accomplished, and just how it changed us. So who am I? I was formally educated as an electrical engineer, and I've also fulfilled roles as engineering manager and project manager using waterfall workflows. In October of 2015, I experienced certified Scrum Master training from Angela Druckmann. I don't know if any of you have ever worked with her. And I got my certification. I currently work as a product owner and a principal development engineer. And I have chosen to remain very hands-on with hardware development over the years, just because I enjoy it, and I enjoy learning with people and teaching them to do it as well. The company I work for is Dynon Avionics. It was founded in 2000 by a former semiconductor executive from Cypress Semiconductor. He had a passion for flying, and he founded this company to build a very simple aviation instrument. How many of you are familiar with an angle of attack indicator? Okay, so he wanted to build an angle of attack indicator. But about 2 or 3 days into the project, he decided he wanted to build something that was 10 instruments in one and sell it for $2,000 instead of $20,000. So he hired a bunch of very young engineers right out of Seattle Pacific University up in Seattle, and put them all in a room and said, we're going to make this thing. And then in 2003, they came out with the EFIS D10. I don't have one here, but if you go to the website, you can see it. It ended up being a wild success. It gave experimental aviation pilots a very reliable avionics solution at approximately 1/10 the cost of the nearest competitive device. So fast forward to the present. Who are we now? We're 3 companies. We design, manufacture, sell, and support an airplane, which you see in the presentation. We have 2 fully featured avionics brands, one based out of Woodinville and one based out of Canby, Oregon. And we have a quick panel system, which you can see here in the lower right-hand corner of your screen. And the special thing there is, so we have customers that build their own airplanes in like their garages or their hangars. It's like a big model kit. And you'd think that'd be scary, right? You're cutting and bending sheet metal and riveting things. But the scariest part to these guys is taking these things and putting them in a panel and hooking up about 400 wires between everything. Because if you hook up one wrong wire and you turn it on, the smoke comes out of the electronics, right? And that's not under warranty. So that is scary. So we do that for them. It probably saves them between 200 and 300 hours worth of labor anyways. So there is a value proposition there. So an important part of the context here about why we switched to Scrum is our typical annual development cycle from a developer's perspective. This is not from the owner-founder's perspective, but from somebody who's actually making things. So product development seems to revolve around air show season, which occurs from spring to late summer. During air show season, staff members, competitors, partners, and industry leaders share their latest and greatest designs and services with the general aviation community at various fly-ins. Those in attendance scope out what's happening, gather competitive intel, and return to home base inspired to do better the next air show season. Then we attempt to wrap in what we learned and where we want to go into a coherent product launch strategy during the rest of the year. Oshkosh, out in Wisconsin, is the granddaddy of all the air shows. Just for reference, in 2014, over 500,000 people attended from 69 countries, 10,000 aircraft flew in, there were approximately 2,000 show planes, almost 800 commercial exhibitors, and over 900 media representatives. During the week of the show, the control tower at this little tiny airport in Wisconsin is the busiest control tower in the world. And the unspoken rule in all of this is that you must have something big to show at Oshkosh. It's the show. You have to do something there. If you don't, you might as well just not go. Something happened during the second half of 2015, though. Air show season came and went. As usual, we had some big announcements at Oshkosh 2015, but we were at least months away from delivering. We had a project which involved firmware development in India, custom parts fabrication in China, hardware development in Woodinville, Washington, software development in Washington and Oregon, and a strategic partner in Arizona. With all these moving pieces, we were thrashing, falling behind, and struggling to figure out how we could deliver on the promises and come up with something in time for next year's Oshkosh. We realized that our products were growing. Did you guys recognize this chart? All the Agilists in the audience. We realized that our products were growing increasingly more complex over time. Right smack dab there in the middle of complex. Managing development efforts across multiple locations added to the difficulty. Given this and the fact that we felt like our backs were against the wall, we figured we had nothing to lose by considering and trying Scrum. Why not? So in October of 2015, we hired Angela Druckman for 3 days of off-site certified Scrum Master training. We were looking to change behavior, not just process. So I'm hammering home on behavior, behavior, behavior. It's not about process, it's about behavior. So we went all in. All of our software and hardware developers from Canby and Woodinville attended, along with our senior management and our founder CEO. We all went. Some of us were sold, others were skeptical, including owner CEO. But we decided to go Agile shortly thereafter. What did we have to lose? How much worse could it get? The 3-day break away from the day-to-day grind was good for all of us. It gave us a chance to have some fun together. Have you guys ever done certified Scrum Master training in a fun environment? Isn't it fun? If you haven't, I recommend it. It's hire a good person to teach you and go off-site for a few days. It's a great time. It gave us a chance to have some fun together, learn how to approach, organize, and prioritize work differently, especially when everything isn't known ahead of time. It also gave us a fresh can-do attitude. Afterwards, senior management and technical leaders held a strategy session in early November and came up with a 4-pronged approach to rolling out Scrum in the organization while delivering new products to our customers at different price and functionality points. And what better way to galvanize a bunch of aviation nerds than with NASA's series of projects which eventually put astronauts on the moon? Our 4-pronged approach included projects Mercury, Gemini, Apollo, and Rover. So Mercury being, can we get to space and live a little bit? Gemini being, can we get to space and live for a while and do stuff that's useful? Apollo meaning, can we get to the moon and land and do stuff and come back up and come back home? And Rover, which is, can we drive around the moon faster? Dynon's approach was, if NASA was, can we get to space and be there and survive and come home? It's, let's just try Scrum. So Mercury was a purely software effort to simplify an existing product. Gemini, which was a refresh of our flagship display product, so these right here, this was our Gemini project. And that's what the rest of this slide deck is about. Apollo has not come to fruition just because we rocked it with Gemini. We don't need to do Apollo in the next few years, I don't think. The Rover project is currently in progress, and it's this little guy right here. So December of 2015 came. We had put together some Agile teams in November of 2015, and December was really, really hard. I don't know has anybody here been through an Agile transformation? Okay, so you know. We continue to have our teams gel. We struggled with filling the product owner and Scrum Master roles. I originally started off as a PO, but it wasn't for me at that time. So I switched to being a Scrum Master, and it was a perfect fit at the time. We also moved into open and collaborative spaces. So we tore down all of our cubicle walls, and nobody was able to hide anything or anywhere. And a lot of people were really scared. In our first retrospectives, we had people saying, I feel underutilized. Are we doing this right? Why did we have to move? I really liked my desk in my cubicle where I didn't have to talk to anybody. Is a 2-week sprint the right time box? I don't really feel like I met done criteria. I don't really feel like I know what done criteria is. And the other questions from a hardware perspective, like how do we wrap configuration management into this? How are we going to do NPI to a manufacturing floor? So we were struggling. But then January 2016 came, and it was worse. It was the nadir of our transition to Scrum. It was awful. We were releasing a new GPS product, which we had promised summer of 2015. This was the thing we were supposed to start selling Oshkosh 2015. And we were still trying to figure out the balance of getting planning, estimating, grooming, and commitments right. In our first sprint of January, which was abbreviated due to a long holiday, my team committed to 51 points. We used the relative estimation of 1, 2, 4, 8, and 16. There were lots of 8s and 16s in there. I'll talk about that in a little bit. We ended up delivering 40 points, along with approximately 120 hours of interruption labor outside of our sprint. So we were all very tired, and it was a very hard retrospective to attend. Things we learned at that retrospective were don't overcommit. It's always a good idea before you start your sprint planning, how many days are we actually in the office? And who's going to be here? So that was one of the things before we commit to anything, days and people, how many are going to be here? We also decided to keep stories small to medium size. So those, maybe a 1, maybe a 2, a 4, never an 8, and definitely never, ever a 16. Because once you get to 8s and 16s, there's something you don't know in there, and that's why it's so enormous, because you can't go 32. At least we never did. And there's some other notes on what product leadership and teams were doing. So we're still getting ready for Oshkosh 2016. So leaders were coming up with product visions, and we were also researching and interviewing industrial design firms, because we figured, I mean, the feedback we got on this display right here was, like, it's cool, but it looks like it's out of a 1970s Soviet fighter jet. And our main competitor, who is Garmin, who you might know. Is there anybody from Garmin here tonight? Don't be ashamed. I didn't think there would be. But so we're like, we got to go big on this. So we found an industrial design firm. I'll talk more about that later. It was interesting wrapping them into the whole Agile process as well, and they were so into it. So late January was a completely different story. That early January was a wake-up call in our transition. We implemented some practical changes based on the previous retrospective, and it really paid off. The team met its commitment, but the ultimate thing that happened was that our behaviors had started to change. We genuinely started swarming stories, even if we were unsure how to help. We also lightened up a bit. We had to. We were being too serious. We installed a GameCube in the break room. We had snacks and wine and beer at retrospectives. One thing I found is that beer and wine at retrospectives gets people talking more openly about how they really feel about things. So if you haven't tried that and you're like, gosh, why aren't people telling me what I really need to hear? Try it, if it's okay at your company. And we provide, as a Scrum Master, I have little kids, so I know that people like healthy snacks, crunchy, salty carbs. So I started providing those things, and the morale started to go up. So, but developer sentiments during the retrospective also reflected. Yes. Oh, she has a Post-it. But the two big things from the retrospective at late January, I think we're getting this sprint thing down. People started to feel like they knew what was going on, like they knew what was expected of them. They knew the done criteria. They knew the routine. And people were feeling energized. When you meet a commitment and you start figuring things out, you feel energized. So, but February, oh man, February was even better than late January. So a vision of what to do by Oshkosh 2016 and who would help us was still up in the air. But leadership was also starting to ask different questions. Not, you shall do this by this time, I don't care how long it takes or how late you have to stay, but what could we do by Oshkosh 2016 at a sustainable pace? And then on the developer side, teams reached consensus on norms. Done criteria continued to be refined, and the team had developed mutual trust. We had each other's backs. We were there to help. I mean, we had started to gel. The team norms was probably one of the biggest turning points for the team. We kept it simple. They didn't have to be complicated. They just simple of If you have a problem with a story, say something. If something's unclear, don't be afraid to talk. No criticizing for asking dumb questions. Like those types of things, because you have to feel psychologically safe in a team room to work together, especially when things are unknown. And usually if you have a question and something's unclear, somebody else is probably thinking the same thing. So by March of 2016, we had crafted a product vision to reveal a redesigned primary flight display at Oshkosh 2016. We had rallied the teams around it and cemented a relationship with a respected industrial design firm in Seattle called Tactile. Has anybody heard of Tactile in Seattle? They do a lot of work with Microsoft and Xbox, and they've helped like Tektronix with their new oscilloscopes. They do design language and user interface and user experience. I highly recommend them. They were top notch. They jumped at the opportunity to work in general aviation. They're like, well, we don't have to work on Xbox controllers. So in order to get them a baseline for the typical user experience for our avionics, we took them on a handful of flights with different pilots in our organization. We have lots of certified flight instructors and pilots. So there's probably 15 pilots within our organization. And we have several airplanes which are usually available to us. And we have, well, at the time we had these installed in them, but they've switched over to these. So they had a great time, learned a ton, and then they got to work on some industrial design concepts for us, which I'll cover that later. So now that I've set the stage for this epic goal, this small scrappy team that's still trying to figure out how to make hardware with Scrum, how do we do it? Did it work? Did we ship something? Did we show anything? So we started with a great functional product, which gave us a great head start. We didn't have to come up with something from scratch or make really hard system architectural decisions. Many of the subassemblies and components could be used without modification. Those that needed to be replaced or revised became the focus of the effort. We had a head start on researching and sampling LCDs for several months, just because of the complexities of incorporating them into an assembly and the need to set ourselves up for success for the next 8 to 10 years with the right product and the right vendor. So like we know that LCDs are hard, especially when they come to Taiwan, and super typhoons can totally screw up everything. So you got to stay out ahead of that. By this time, we had samples in hand and had decided on a resolution, a brightness, a surface finish, and a design envelope, but we hadn't, however, decided on cosmetic appearance, which is the custom cover glass and the branding that you see there. So once we had the product vision, the hardware engineering team reviewed the product vision. We broke down the hardware product requirements into epics and stories based on affected subassemblies and components. So in this picture you see here, the large pink Post-it notes represent subassemblies or larger components that were new or needed revision. The smaller pink Post-it notes represented self-contained modules of functionality that could be completed in small or medium-sized stories. So by this time we had learned, don't do 8s and 16s. Break it down as far as you can go. But sometimes from a hardware perspective, there is a limit. Like sometimes you need resistors, capacitors, inductors, MOSFETs, and power supply control chips just to have a working power supply with an input and an output. You can only break it down so far. Once we had this initial planning done, we populated and prioritized a backlog based on the axes of lead times, risk, and complexity. So here's a sample user story. So as an electrical engineer, I prototyped the Skyview X LCD backlight and control PCBAs for the 10-inch and 7-inch LCD panels so that I can eliminate this risk from the project. Our acceptance criteria was the schematic was complete, the PCB layout was complete, we had configuration management done, we had enough printed circuit boards built to demonstrate that it worked, and then the PCBAs were tested and characterized. So most LCDs need a backlight unless you have an OLED or something. LED backlights require constant current controllers. This particular solution also required a DC to DC boost power supply to get the voltage high enough to drive current through the string of LEDs in the LCD. By asking ourselves, how can we fit this into a sprint, we were forced to do the following. We kept it simple, we modularized it, and we did our best to, and we actually tested it without a target LCD so that we, like, when you first turned it on, we had like 5 samples. We didn't want to destroy them. Before we switched to Scrum, though, we would have incorporated this new circuitry into our main carrier board. So our carrier board has something like 10 power supplies. It's got a big seated connector for the motherboard. It's got I/O connectors. It's got a solid state drive mounted on it. So what we would have done was incorporated this change and probably 8 or 9 other changes into that main carrier board. And the process to design it all would have taken probably 1.5 to 2 months. Luckily, we have a surface mount line in-house, and with quick turn PCBs, we can turn these designs around in about a week and a half to have working prototypes done. But had we waited 2.5 months, we would have applied power, turned it on, and something would have been suboptimal. And we all know that means the smoke comes out or just straight up doesn't work, and then you're having to make a spaghetti mess on your pretty prototype. But by living within the constraints of simplicity, modularity, and a little creativity, we were able to quickly learn and optimize the circuitry without risking damage to any other electronic assemblies. Keeping it simple kept the bill of materials short, costs down, and made it more manufacturable. The solution ended up being so good that we just ended up keeping this board that you see on the slide here, and we tape it to the back of the LCD. We accomplished this story in 2 weeks by leveraging quick turn printed circuit board assemblies, DigiKey, the local nerdy electronic hardware store. So up there we have like the version of Fry's. We just go there and buy some parts sometimes. And we use a little imagination as well. So back to Tactile. They took about 30 days to experience and understand our products, ask questions, brainstorm, and come up with some concepts. Here are their initial design concepts, A through F. So we did an internal poll and we sent these out to very trusted customers. And the feedback heavily favored A. I mean, it looks almost like that, except just a cosmetic update. And the thoughts surrounding B through E were, well, there's some nice things I like about it, but meh. Concept F was an enigma. People were like, I really like A, B through E are meh, F is weird. It makes me really uncomfortable, but I just want to put it in my airplane and fly it. I just want to see it in life, just to see if I'd like it. So what did we say? What did we do? We decided to go for F. We needed to go big or go home. So we thought it was fresh. It was ergonomically superior. And that F has this D-pad thing on it. So D-pad, video games, DSLRs. We thought, wouldn't that be cool if we could use a D-pad instead of a touch screen to move the map around? Because, you know, in an airplane, you might be doing this, and it's kind of hard to touch a screen and pan and zoom and do those commonly used gestures. So we thought, let's try it. But we were running out of time. So making changes like this in general aviation is kind of a big deal. People are trained and trained and trained and trained, and they get used to doing things in a certain way. And if we threw a D-pad in the cockpit, you know, it's like, for us guys that play video games and stuff, like, yeah, D-pad, cool, right? But for a 67-year-old dude or a 78-year-old guy, he'd be like, the hell, you know? So we wanted to make sure we didn't turn anybody off. So the story you see above it's long and has lots of tiny text. I won't read it. The spirit of the story is, how can we figure out within one sprint if that D-pad is a good idea, or if this like F concept is even worth pursuing? So what we did was we 3D printed the F concept, as you can see here, and we printed off what our display looks like and glued it to the front of a 3D print, and we showed it to people. Like, what do you think about this? And the reactions were mixed, but it was still like, oh yeah, this is a good idea. So then what we did was we said, all right, let's take this one step further. So we built a James Bond briefcase prototype, like you see here. We ended up using in-house hardware. We used a sample LCD. I went to Target and I bought a Logitech USB PC game controller. And I chopped it up and I used the part of the printed circuit board behind the D-pad, and I ran the little 30 gauge wires. I hooked it up to an Arduino. I wrote a custom sketch. I then rerouted it into the real-time input-output controller for this display and tricked it into thinking somebody was using one of those knobs to move it around. So we had a fully functional D-pad which moved the map around. We then, oh yeah, I went to Home Depot too. We learned several things during the user testing. The D-pad, awful. No one liked it. It was terrible. So we got rid of it. It was stupid. But users loved that angled shelf. They liked the new knobs, which were part of the product vision for this. So when you come up here, or if you happen to come up here, feel the way that this knob feels from a user experience versus the way that this knob feels. Just do it, trust me. It's a big difference. It'll make you want to buy one. And the new screen. There's a brand new LCD on there, which made a huge improvement. People love that too. But what I need to drive home here is that the fact that we kept the prototype quick, ugly, and rough, it helped us let go of the D-pad idea very quickly. You know, if you have a technical baby, if you will, and you put it in front of somebody and you're like, tell me my baby's ugly, or tell me how my baby's ugly, that's never any fun. But if you don't put that much time into it, and somebody tells you that that's a terrible idea, but good try, it's not that hard of a pill to swallow. So always keep prototypes as ugly as possible. If it's a good idea, it'll shine through. All the good ideas shown through here, and it gave us some really good insight into what customers would want and what would be useful. So we got rid of the D-pad and we kept everything else. So once we had decided on a design direction, we just went for it. We went nuts. We rapidly built beta test prototypes. You can see here so we use CNC machine mills, or we CNC machine bezels. And then we hacked in some of the old LCDs using some black epoxy. We tried to fill in the spaces around here so it looked like this, but it got close enough. We loaded the new user interface, user experience software on there, and we sent it out to, I think, 10 beta testers. They gave us a ton of feedback in a very short amount of time. They were super excited to do it. And then once we had that feedback down, we wrapped in what we could into the Oshkosh prototypes, which you can see here down in the down here in the lower left-hand corner. This is one of our mechanical engineers who was on our team building those early prototypes with his crazy magnifier glass thingies. But at the end of the day, we had 8 fully functional prototypes ready to go with hours to spare. So hours to spare, literally. Yeah, we went home that day and like just rested. You know how that goes. So Scrum was a game changer at Dynon at all levels. We used to spend countless hours debating the merit of design ideas and fear wasting time doing the wrong thing. Now we bias toward prototyping and trying ideas and iterations. We either win or we learn, but we're always moving forward. We've also benefited from giving developers the power to negotiate and commit, and the space to work and figure out the how. It's been liberating, it's been dignifying, and it's given us much higher employee engagement now that people feel like they can say, like, no, that's not well defined enough, or no, I can't commit to that. But it's hard to get people in that mindset too. So I'm going to close with, if you're going to try using Scrum for hardware development, you need to focus on your mindset first. You need to ask, how can I fit this into smaller chunks of work, as opposed to having some big finished thing that rolls out at the end and it just works. You should also become familiar with rapid prototyping methods and technologies. Bias towards learning and lots of iterations. It will result in a relatively mature product in a very short amount of time. We started on this in October of last year, and we're on revision 8 now of the hardware inside. And we've had to deal with a lot of emerging requirements because it was a clean sheet design, but it's moving very quickly. As far as teams go, it took us about 3 months to feel like we were doing it right. What's been your experience?
I personally have only been doing it for about a week and a half, 2 weeks.
Okay, so.
Other people in the same group.
Yeah, is anybody else in the same boat? Kinda? Yeah? Yeah, it was really difficult at first. So if you have questions later, let me know, and I'll walk you through how we helped get through it. But make sure you treat the roles with respect they deserve. Give your developers space. Make sure your product owner is paying adequate attention to the backlog, its grooming, and its prioritization. And your Scrum Master needs to be an empathetic listener and also be good at conflict and resolving it, just wading in. And the ability to estimate, negotiate, and commit, it takes a lot of time, especially in an organization where people were used to be told exactly what to do and how. Also try experimenting with only small and medium-sized stories. If the story's too big, like I said before, you're probably missing something and it might explode mid-sprint. And one last thing. So I don't know if you noticed in some of my earlier slides on the, I'll go back. We used a lot of data to change the organization. So one of the things that our Scrum trainer told us was that if you do Scrum right, it will expose organizational weakness and gaps. And that's exactly what it did. So in this retrospective or this interruptions data burn down chart picture I have here from early January 2016, you see all the tick marks there? We tracked hours of interruptions, we color coded them from their source, and then after we had 2 or 3 months of data, we saw trends, who knew? And so we actually repurposed people in the organization to fill those gaps. And what that did for us was it greased the squeaky wheel. It got people where they needed to be fixing things and improving processes. And it also protected our development teams from constantly being interrupted by production and customer support. So be careful and be considerate about what data you track. So that is all I have for now.
All right. So as you see, we have a lot of questions to vote on up there. You can we can take about 3 minutes to get up to the front. 5 minutes it's really going to take, and then we'll just have to shut it down for folks to get up and vote on some Post-it notes. And then Nora is going to rapidly prioritize them for Kris. And Kris, you are going to have so many questions to take with you to the pub, so I'm glad we did it this way. And maybe even some questions to do in Slack. So go ahead and refresh your glasses, take your pens, come to the front, and we will really watch this to a strict 5 minutes.
I got a time box.
Okay, excellent.
Okay. Yeah.
Scrum help you improve the quality of the product that you brought out for the first time?
Yes.
Okay.
Absolutely.
Okay.
It did.
So how did you?
Button and hold it and move it around. We won't ruin it. So we do the high reliability testing on these, so we beat them up. We're having it set in there. Try it on. So we had to use up that first GPI with a touch screen to see.
Scrum help you
We shipped in October. We had a absolutely. Well, so what we did was we're like, okay, what if we find more emerging?
So how did you when it came to like the validation of? I mean, you're making complex circuits and stuff like that. How were you able to make?
You ready to start?
Yep, I have the
Give me my first
highest one. 5 votes.
How do you plan for something needed 1 year from now? Okay, who's asking that? You guys? Yeah, that was the problem we had. So,
or maybe not so much plan, but maybe like commit, right?
Commit.
You only plan 2 weeks in advance. How do you commit to something a year out, like
Right.
the next trade show or the next?
So when we were in Scrum training, we asked the same exact question. Like, so, you know, we use, I mean, we obviously have a complex electronic assembly, right? It's got a custom LCD panel, and I can't just call the local custom LCD office in Taiwan and tell them I want this, 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 and this, and you shall have it to me in 2 weeks, and please include shipping in that. So what we did was, I mean, I got to be honest with you, even before I knew we needed to do this, I had started on LCD vendor relationships like a year out. because the LCD in here, it went obsolete the day we shipped it. So they're like from like an Acer notebook or something. And we found a bunch of them at a huge discount, and then we got them high brightened. And they were end of life. And then, so I had started with, I forget the vendor's name, but I had 2 or 3 in the running, and we sampled. And by early January of that year, we were actively like, okay, here's purchase orders for samples. Give me quotes on what this custom cover glass would look like. By the time we needed to go to Oshkosh, we didn't have the fully assembled thing. We actually had to go to Home Depot and cut glass and spray paint it and silk screen it ourselves, and just overlay it. But it worked just fine for working prototypes. So yeah, Scrum didn't help us with that, but having a vision of knowing where to go and like treating that like it maybe on the whiteboard, things not too weakable, get an LCD, and make sure somebody owns it and knows when, and it's, you might not have all the requirements at first, but if you start working with the right vendor early enough, and you have a vision of where you want to go, it is doable. But and then if you need to do work, you fold it into the sprint. So if we had something to do, it was okay. Turn on get the LVDS timings and the touchscreen going for the user interface and user experience. That's how we handled it. Does that? Yeah. Okay.
Here's the next one.
How did you build cross-functional teams across for far-flung locations? Well, I'm actually going through that right now. This did not need a cross-functional team across locations. Everybody was in our building. Granted, we had designers in Seattle. Who asked this question? Okay, so I'll address you. So we made sure that we were in contact with Tactile at least once a week, if not twice a week. We would drive down there and just hang out. Do you guys have questions? Do you guys know where we're going with this? Here's what we're doing in our sprint. And they tell us, here's what we're doing. They shared their Pinterest inspirational boards with us. I remember getting to the point where I was kind of panicked in this project because people had told me, yeah, you can get an LCD order going without knowing what the custom cover glass looks like. But then my vendor said, absolutely not. They're not starting on anything until you have everything signed off and ready to go. So there was, luckily we had been going down there at least once a week, and I was able to use my next week trip to be like, guys, give me a design that is not quite what you had in your industrial design concepts, but uses just a rectangle, and we can build around that.
Telling us how you started out telling us how you had firmware from, I've forgotten, India.
Yes.
And this from this.
So that was a different product, and we never really figured out how to do it well. So that's so when things weren't going well, we had to get our partner in Arizona, who was the owner of the company in India, to get them to really ratchet up their efforts. And we would have probably a telecon with them every Tuesday and every Thursday. And they would, on Tuesdays, it would be our mornings and they'd be their nights. And on Thursdays, it was our nights and their mornings. So, doing email back and forth, that was not working.
Okay, so you have not applied this process to that type of a team?
I am right now with this product. So this product is being co-developed between Woodinville and the Canby office. Manufacturing and a lot of the hardware development is going on up there I take that back.
They're at least in the same time zone though?
Yeah, we're all in the same time zone, so that makes it super easy. We have daily stand-ups with Zoom. We have a hardware manufacturing quality team and then a software firmware team. I'm the liaison between those two teams, and we have a shared backlog and a Kanban board and a product vision, which we're always referencing. So yeah, Zoom, regular meetings, deploy tech. It's cheap to get somebody a webcam and a headset. Amazon Prime that. And as long as you get people in a remote first collaboration mindset where you don't have people like, oh, hey, Nora, I have a question. What should we do about this resistor right here? Should we use this 10K or 11K? 11K, okay. We have those in stock, okay. Just make that decision for the rest of the team. Well, I'll just tell them. Don't do that. Don't make split decisions at people's desks. You have to have, I mean, that was a super simple example. No one's going to care about an 11K resistor. But if you have a big decision to make or a moderate decision to make, you have to have a remote first team mindset, because it's going to disengage the other people who aren't around and get them to the point where it's like, you don't need my input? Fine. Good?
Yeah.
Okay. How do you integrate physical design of circuits, timing, layout, into the development cycle? Can you elaborate a little bit?
So I'm proxying this for a few people, but I've been on a development team that's building hardware where the traditional process was to do front-end design, circuit, logic design, and followed by layout and timing would be much, much later. And the result of this would be late discovery of issues and of course, the rework that involved. So as you're dealing with the actual, with the physical circuit board, you have things like getting a signal across the board, dealing with RF interference, characteristics like that. How did you, if any way, did you pull those forward and make those people involved in your team?
This is a really good question. So I will admit there are some things in hardware that you cannot test until it's all together in this box, right? Okay, so I have a transmission line, it's a SATA line, and I got a bunch of wiggles on there, and there's actually data being stored in the printed circuit board. How do you test that without having a fully working thing? Is it bad if I say you really can't? I'm serious,
So I don't think it's a bad thing to say you can't finally know if it works till the very last integration, but you do there certainly has to be some way to get some early detection.
Yes, absolutely.
And to make sure that those people aren't waiting on other people's work, breaking team dependencies.
Yes.
Really hard to keep up.
It absolutely is.
At the end of your process, there's a lot of risk.
It is.
How can you mitigate that risk?
So I'll tell you a story. It involves a SATA DOM. Anybody use a SATA DOM? Single level cell, industrial grade, $45 for 4 gigabytes. Terrible deal. When we first released this product, it had a SATA DOM in it, and it had a high-speed SATA line that was, I don't know, 2 millimeters long. We kept it really short so we didn't have to deal with it. That was our first mitigation of risk, right? Keep it short. One vendor, one part from that vendor, and so we installed it, and we always had problems with it. Come 2013, these displays started like freezing up in the field, okay? So now we've gotten failures in the field from hard debug things. And we went back and forth with the vendor, like things are not well here, what's going on? We found that there were SATA exceptions in our, I'm not really a Linux person, but if you do the, grep, SATA exceptions, like just, and every time there was a SATA exception, the display process would go out to lunch, and then the SATA DOM would eventually get reset, and it would come back online. It would take anywhere between like 2 and 10 seconds. This is bad because that's misleading information on a display. What we figured out, we had done the layout right all along. The SATA DOM was incompatible with our chipset. And I could plug in any solid state drive or any hard drive into this hardware right here and it worked just fine. I could plug in that SATA DOM to any other chipset and it worked just fine. Put the two together and they just didn't match up at all. So what we did in this, and so we migrated to M.2s. And what we did in order to rapidly prototype that was we built a new carrier board with an M2 SATA drive in it. And between the time that we had taken off the SATA DOM, designed in a new M2 with a power supply that did all the right power management things. It was 2 weeks between the time I ordered, sent my Gerber files in, and I had prototype printed circuit board assemblies back. We turned them on. We looked for SATA exceptions. We don't have signal integrity equipment, but we went cold, we went hot, and they were rock solid. So I guess how we do it is we just say, how fast can I go, or how fast do I need to go, and then how am I going to get there? And I bet we probably spent $1,000 on quick turn boards, but at the end of the day, $1,000 and 2 weeks to show that our new implementation fixed that problem, it was totally worthwhile. Oh, yeah, okay.
Few minutes.
Few minutes. So is this the last one? Okay. How to negotiate scope when product is highly integrated.
Does that make sense? Does that make sense?
Elaborate, please.
I work at a large company that makes very large, highly integrated circuits. And
okay.
They're modular to a point.
Yeah.
But similar to the last question, they once you get them put together and start the process of sampling and validating and testing, it's really hard to say, oh, that part isn't working.
Mm-hmm.
I'm not going to use that anymore.
Yeah.
Right? It all has to get done.
Yeah.
It's in, it's got to be in, it can't come out. And then if you need to have the part ready to ship for a certain market window, that's all got to be done too.
Yeah.
And so you get between a rock and a hard place. And basically the bottom line is what I hear from the teams is, we can't say no. We can't negotiate scope. It's in there, it can't come out, and it has to be done by a certain point. So it's just do it, suck it up, get it done. Do you have a similar problem?
Yes and no. So we're not as highly integrated as that, obviously. We buy those things. And if it doesn't work in our system, we either figure out why or replace it with something that does. Right now I'm struggling with I was struggling with the little modular GPS receiver in this guy. There's nothing I could do to make it work. The applications engineers at the company I was working with were not very helpful either. So I switched to a different vendor, and it's been a night and day difference. And we've applied what we've learned from that first and second iteration with the feedback we got from the apps engineering team at this new vendor. And we're just about to order those GPS receivers. But back to your question of how do you negotiate scope when product is highly integrated? We fall back on just trying, learning, iterating, trying, learning, iterating, trying, learning, iterating. And we can wrap a lot of iterations into a very short amount of time.
Yeah, you talked about rapid prototyping too. That might be part of the answer, right? It doesn't go in unless you're pretty sure it's going to work. And you can detect that quickly.
Yeah. So if I need to spin a new carrier board for this, I can do it in about 2 days, have new boards in about 3 days, have them built on my surface mount line up in Woodinville in about 2 days, and then have them back. So we're in a different situation, I think.
It takes us 6 months to spin something new. Yeah.
Just to point out, so 2 quick things on that. So for circuits, simulation capability and also hardware simulation. So things like field programmable gate arrays, ways to verify logic, even in some cases the timing early, and fast feedback.
Yeah, we can't do a gate level, but that's definitely part of the answer for sure.
Did you get your question answered?
All right. Wow. Okay, so it's 8 o'clock, and we need to go answer questions while at the pub, right?
Right. And you're going to be the Pied Piper, and which pub are we going to?
I have the authority.
Yes, you do.
It should be one of the 2 down the street.
I've never been to either one.
Then let's go to Pine Street, I guess.
Do it. The Pine Street one.
All right.
That's where I pick.
Okay, great. So we have to get this place back into puppet shape in less than 30 minutes. If you can help with trash, plates, chairs. And you can go up and play with the equipment. You can go down to the pub. Thanks for coming. Come back next time.